Yeah, and then finally, we'll be going over the natural language processing basics, and then we'll get into some code and some examples with Python. So just a brief introduction about myself. Thomas Zhao. I'm a data science major here at Penn State, as well as an economics minor. The past 2 years, I've interned at an insurance company, as well as a finance company called JP Morgan. And I also do research here at the College of IST. My official title is, quote, research support. So whatever that means. But you can see my brief resume to the right there. All right, so natural language processing. What is it? Is there does anyone have any ideas, first of all? I'm going to ask the audience. What do you guys think when you hear natural language processing? It's not a term I think everyone is aware of. Do we have a chat window?
Hey, so there is a chat window because you're sharing your screen. It's probably
okay.
gonna pop up behind it, but Bella can
No,
keep you
I found
updated if
it.
there are any comments in it. Okay.
Thank you, Kira. All right. Yeah, I'm not used to this webinar stuff. All right. So turning English into code, I mean, that's pretty much, at the very core of it, converting natural language to data we can use. Now that's getting closer to what it is. Okay, understanding languages. Yeah, that's pretty much what we're trying to address. So this is what Wikipedia says. They call it a subfield of linguistics, computer science, and artificial intelligence, concerned with the interactions between computers and human language, in particular, how to program computers to process and analyze large amounts of natural language data. So basically, NLP is, like you've said, having computers trying to understand humans, trying to understand human language. Not all of us talk in C++, and in fact, when we communicate with computers, we're usually not communicating in code. Like Andrea mentioned, Siri, Alexa, this is all natural language communication. And lastly, natural language processing is also, having computers communicate with us, sort of generating natural language. And all three of these are essentially ways of saying the same thing or different perspectives to approaching natural language processing. But you might be wondering, what is NLP? Understanding humans, that's great. Communicating with computers. Now, what does it even mean for a computer to talk to you? Well, that brings us to our second point. Where do you use natural language processing? And how is it being used? Anyone want to give any ideas where it's being used? I know Siri and Alexa have been mentioned. Any other thoughts on how companies are using this type of stuff? Okay, so translation, that's a big area. I'll wait for several more ideas. Security, chatbots. Yeah, definitely lots of bots. Bots are a big industry. I'm curious what you mean by security, Punya, like fraud, because that's another big one. Yeah, analyzing moods, customer support. This is all good stuff. So you guys pretty much got most of it. There are also a lot of cool applications, like, for example, speech to text. This Zoom application has this transcription feature, and it's a hard task converting audio to language, and you need a bit of natural language processing to understand, where to place words into a sentence. And that's also used in things like Siri and Alexa. We also have machine translation, as Kavan mentioned. Big use, chatbots, grammar induction. If you ever use autocorrect, or there's an extension called Grammarly, this is all powered by natural language processing. And finally, there's some really cutting edge stuff like question answering. IBM Watson, for example, won Jeopardy, I think, several years ago. And if any of you have used Wolfram Alpha, you can ask it all sorts of questions and it'll try and answer it. And finally, there's text generation, which is also a bit of a new one. There's this new thing called GPT-3 that can produce text. And if anyone's interested, I highly encourage you to Google GPT-3 apps. There's some crazy stuff like you can type, I want this JavaScript code about, making this sort of button, and GPT-3 will just automatically generate that code. And it's basically translating your English into code. So it's kind of a form of translation as well. So let's get into the basics of NLP so that you can start building your own apps. So there are two main areas that NLP sort of breaks down. There's syntax, which is analyzing our language through grammatical rules. And I think this is the much easier part. Computers like rules, and so grammar is pretty simple. But then there's also semantics, understanding meanings. When we humans say a word, it can mean a million things. And so the semantic part of it is, trying to get computers to understand context. In this workshop, we'll be mainly focusing on syntax, since first of all, you need to get the syntax first before you start understanding semantics. And also, it's just easier to have a workshop on. So the first concept in natural language processing is tokenization. We have text in the form of strings, but to really process it, you got to split the string up into tokens. And so tokens is essentially splitting a string into its constituent words. So that's pretty self-explanatory. You can see this string here, the cat sat on the mat. And then it gets converted to the tokens, and then you see it's all the words. Now, once you get these words into token form, you got to standardize them, because computers, they work better once you sort of remove the noise. And so you can see here, there's this thing called stemming / lemmatization. They're essentially the same word. Stemming just means, you remove the word suffixes, and you can see here, playing goes to play, played goes to play. So you're essentially converting all the words to the root word. And lemmatization it goes farther than stemming. You're not just removing the suffix. You're, like am, are, is, they're all forms of the verb be. And so you're just standardizing these words. This is what stemming and lemmatization is. You can see at the example at the bottom here, the boys' cars are different colors. After lemmatizing it, it becomes the boy car be different color. So this standardization is also necessary to getting computers to understand words. So once you have these words and you have these sentences, you can tag them with part of speech. And part of speech is pretty necessary for, comprehending a sentence, right? And so I don't know if you guys remember your grammar classes, but a sentence has a subject, has nouns, adjectives. And so you can see the sentence NLP is easier than you thought, converted or tagged with these part of speech tags. And the language, the libraries that we use in Python will give you these sort of abbreviations. They're really just mappings that you can see in this little glossary here. And so JJR is like adjective, IN is preposition, U is a personal pronoun, so pretty self-explanatory there. Now is where it starts getting a bit more complicated. There's this thing called dependency parsing in natural language processing, and it's basically where we want to extract the relationships between words. For example, you'll see these graphs when you research dependency parsing. And you'll see like the delivery was very late. Well, was here is the root. Oh, yeah, I can slow down. Sorry, I just want to get to the code, but if you have any questions, definitely ask. Let me see if I can pull up the Q&A. Okay. Well, if you have any questions, please ask. Okay, so let me restart. Dependency parsing is trying to get the relationships between tokens. And so if you have a sentence, there's this whole algorithm that converts the sentence into a sort of tree. And you can see this tree here. It's a bit non-intuitive, which is why I have this cool demo that NLP has released. Let me see if I can open it. All right. So we can take that word or that sentence, the delivery, it's very late. Oh, right. Let me get this demo to you guys. I copy and paste that. There you go. So this is just a more intuitive way to get a feel of what dependency parsing means. So the delivery was, what does end subject means? Well, you can pull up, if you Google dependency parsing spacey, they have this glossary here. You get part of speech. Spacey, by the way, is the language, the library, the Python library we'll be using. But anyways, you can look at this glossary if I can find it. Oh wait, this is just the guide. Let me see if I can find the documentation. Hold on. It. Usage. Okay, annotation specifications. There it is. Right. So dependencies. If you go to English here, you can see what all these labels mean. So end subject. What does end subject mean? In SUBJ, it means nominal subject. And that's basically. Yeah, I was just searching for the annotations I had on another screen. But you can see here, it's just called Annotation Specifications, space documentation. So if you have any questions about what these labels mean, this is a good glossary to go to. All right, English. So nominal subject. And then you can see the is DET, which means, I believe, determinant. Yeah, determiner. And so this gives you an idea of how the words are related. Late is an adverbial or adjectival, no, adverbial modifier, right? ADV mod. So, oh shoot. Okay. Let me see if I can share my screen here. All right, can you guys see that now? Sorry about that. I thought I was sharing my screen. All right, great. So basically I just Googled annotation specifications for spacey. And this tells you all the labels for dependency. And it'll take some time to get used to it, but you can see here, I'll give another example. Let's say the hackers stayed up all night. Right, so stayed here is the root of the tree. You can see here, who stayed? Well, the hackers stayed. That's the subject of the sentence. And, well, stayed up would be a modifier for stayed. All night is, I guess, a noun, but I'm not sure what tmod is. tmod. It's not here. I think Alan might be using a different label system than Spacey. But in any case, you can get an idea of sort of how you can relate different words using dependency parsing. All you need to know is that subjects are in sub. If you want to get adverbs, you get ADV mod, and then there's determinants. Let's have like another example here. Right, thinking, that's a verb, about, preposition. So just a very handy tool when we do NLP. So let's get into some coding. Now you don't need Python installed on your computer. There's this cool website called Colab by Google. You can Google Collabtory, but if you already have Python on your Windows machine, then you can just install Spacey, which is the library we'll be using. And so let me share a Google Drive link with you all. Oh wait, this is annoying. I gotta go back to the presentation. Okay. So you guys can see the Colab link. Is there a way, Isabella, that I can just share my screen instead of like one window?
I think it would be in your share options. However, I think you do need to keep switching it like you were doing before.
Okay. Yeah, I thought there was just a screen option, but I got to keep switching between.
Right.
All right. So let me open up Google Colab then, and we can get started with some coding examples. And I'm going to share a Google Drive link with you all, just so you guys don't have to retype all my code. So if you go to that Google Drive, there's a Python notebook there. And let me share my Chrome. Can you all see my Chrome?
Yeah, we can see it.
Awesome. So once you have this Google Drive, you can just open this up with Google Collabtory, and we can get started with some coding examples. All right, I have the chat back up. If you have any questions, just throw them in the chat. Christopher, did you see the link for the Google Drive? Wait, let me give the Collabtory link to you guys too. Oh wait, I was sending it to panelists, attendees. There we go. Sorry about that. I'm too used to being a normal attendee that I didn't know that there's that drop down. There we go. So once you load up that Python notebook, we can get started with some coding examples. So let me know when you guys are ready to do some Python. Just throw it in the chat if you're set up with Colab or if you have any problems. What do you mean right link? So I sent a Google Drive, which is where we'll be getting the data. Inside that Google Drive is also a Python notebook. Oh wait, here, let me send a new link. Let me know if that link works. All right. Great. So you should be getting this Python notebook. You should be able to open it with Google Collaboratory. If not, you can also load it in from the file dropdown in Collaboratory itself. So, are we ready? Everyone has Colab up? Sounds good. So, I've typed out everything just to save us some time. The main library we'll be using is called Spacey. And Spacey has this NLP object, which you call using spacey.load. You can do all sorts of different languages. I'm using English, so this is why I have this string here. So once you create this NLP object, you can do pretty much all the things I mentioned to you in the PowerPoint. So I'm going to do an example sentence here. Stayed up all night. And so Spacey automatically tokenizes this sentence for you. Once you call NLP on it, you can see here, you can just iterate through it like a normal Python object using a simple for each for loop. And then there's this token.text attribute. And so you can get the tokens just by feeding it into this NLP object. Now, Spacey does a lot of things behind the scenes for you, so you don't need to worry about coding up what lemmatization is. For example, Spacey automatically has dilemmas for you. You can see here, hackers becomes hacker singular, stay becomes stay. So that's pretty nice. You get this lemmatization feature from Spacey. You also get part of speech tags. So hackers noun, stayed verb, and then determiners noun. So that's all pretty cool. Now, one neat feature, because almost no one memorizes all these tags, you can use spacey.explain to look up what you don't know. So what is DET? Well, spacey.explain will tell you it's a determiner. Punct is punctuation. What is ADP? Add position, whatever that means. So this is a pretty handy tool. Spacey also does dependency parsing for you. And so you can see here, the is DT, hackers is the nominal subject of the sentence, state is the root of the sentence. And again, you can use spacey.explain to figure out what you don't know. Like, what is ADV mod? Adverbial modifier. Great. Now, there's a lot of cool things that Spacey offers, such as entity recognition. Now, I don't know if I have any entities in that sentence. Okay, all night. So that's a time entity. And you can do spacey.explain time. And it shows time means time is smaller than a day. Let's try a new sentence with anyone have any cool sentences related to companies or something? Any sentences we can try? Busy is the new stupid. Okay. And I'll add Kavan's sentence as well, and neural networks are related. All right. So let's see what the dependency parsing looks like. All right, busy is a noun subject, and it's actually cool. It sort of adapts to the context. So in this case, busy is not an adjective, it's a nominal subject. And then we can have a look at the entities. Oh, we have no entities in here. All right, let's try adding an entity just so I can show you the demo. Let's try the neural networks from Google are lit. Okay, now let's see what entity recognition shows us. Okay, Google. And so Spacey automatically tags Google as an organization. You can see work means companies and agencies, that type of stuff. So that's pretty cool. There's also noun chunks, because some nouns, well, I'll just run this to show you. Some nouns sometimes aren't just one word, they're two words. So there's this dot noun chunks function that you can use to extract noun chunks. So there's a lot of advanced NLP features that Spatie offers in a relatively simple way. And finally, we can easily split sentences apart with Spatie. So that's pretty self-explanatory. All right, next, let's do some examples. So in the Google Drive, there should be an election-related tweets.json. You can download that. And once you download that, you can upload it into Google Colab. Hopefully this doesn't take too long. If you're doing it on Windows, you can just pass in the path to the file name. Right, so once you have that uploaded, you can load it into Google Colab with this bytes.io thing. And then we'll read it line by line. And I have it in JSON format. Basically, it's think of each line as Python dictionary. And I got to change that to right. I think that's what I have it. Okay, and this is what I mean by Python dictionary. So each line is basically this dictionary that I loaded using JSON.loads. And you can see different aspects of the tweet here. What we're concerned about is the text, because that's where the natural language is. And so let's just get the tweet text. Now we can have a look at the first 10 tweets. These are election-related tweets, by the way, so they're bound to be toxic, but this is what it looks like. And so first we'll want to, in any good data science sort of functionality, we'll want to clean the data. So in this function here, we're removing @signs, hashtags. This regular expression here is going to be removing links. And finally, we'll be stripping the white space from the end and adding a period, just in case we want to look at the sentences. So I define that function. We can now get a cleaned version of our data. And you can see here, no more hashtags, no more @signs. And now we can finally get started with some natural language processing. So in this example, I'm just going to filter tweets by dependency. And I'll show you why it can be helpful. So in this function here, it's taking in our tweet list, a keyword that we want to look at, and then a set of dependencies. The collab about machine learning. Did you get this file here? HackPSU NLP? Because I have it in a IPython file. The only thing I have here is the election tweets and the Python notebook. What aren't you seeing, Ellen? Are not seeing the? Okay, Aldison sees it. All you need for this section, Ellen, is just a notebook file and the more elections data, or the election related. Wait, so you don't see this election related data, Ellen? Let me see if I can share this. So So you don't see the whole folder. That's strange. Get link. Anyone with a link? Copy link. All right, try this folder here. Yep, no problem. Hopefully this works. All right. Awesome. So you can see all these files that I have here. It's just for a quick demo. So once you load in the election tweets and clean it, we can finally get to natural language processing. And in this case, I'm going to be using dependency. I'm going to be filtering. So I'm going to look through each tweet. I'm going to look at the keyword. And for example, so the reason why I'm doing this is I want to see what people are saying about, for example, Trump. And so in this case, our keyword would be Trump. So if the keyword's not in the tweet, we'll continue. And if it is, or if it's not in the tweet, we'll skip it. And if it is, we'll convert it to an NLP object. Using the synthesizer, we'll look at each sentence. We'll check that sentence if the token is the keyword and that token has the dependency that we want, then we'll add it to the final filtered data. So we get this filtered data, and I'll show you what we can do with it. So first, I want to look at what people are saying about Trump when Trump is the nominal subject of the sentence. So you can see here it's filtering all these tweets here. This is, you'll see what I mean, I think, once I explain what I'm actually doing. But if you're wondering by the dependency, have a look at this Annotation Specifications page on Spacy. And if you scroll down to this English section under Syntactic Dependency Parsing, you can see all the dependency labels. And so what I mean by what dependency we want, like for example, I want to look at the word that is the nominal subject of the sentence, aka the main subject of the sentence. I don't want the word when it's, for example, being used as a verb or being used as the direct object. I want it as the subject of the sentence. And so that's why I'm filtering by the dependency here. You can filter by whatever you want in your own applications. For example, you can filter by part of speech. You can filter, if the verb's a noun, or if the word is a verb, you can filter by that. Okay, so it looks like it's done filtering. Now I'm going to download the output here using this here. So we have all this, we have all these sentences. Now there's this cool website called Wordtree, and I'm going to use it for visualization. So Wordtrees generates essentially a tree of all the possibilities of how the word in question is being used. And so Trump here, if we reverse the tree, we can see what people are saying about Trump. And so this is quite toxic, but that's to be expected. And this visualization is mainly to give you guys a better idea of what you can do with dependency. For example, if you want to look at what kind of adjectives are related to Trump, you can use dependency to parse that. What kind of, are the adjectives positive? Are they negative? So let's do another example here. So let's instead just look at the word election. Let's see what people are saying about the election in general. So we'll filter here. I was going to use a bigger tweet data set, but it turns out this is actually pretty slow, so I only have a couple hundred tweets in this data set. All right, so let's have a similar visualization here, but this time about the word election. So at the top, you type in your keyword, and it'll get you what people are saying on Twitter about the election. So the election is about Trump versus the people. It's about 2020. And so you can also reverse the tree. But let me give you an example of why the dependency matters. So for example, let's see what happens when we're looking at the election when it's a direct object in the sentence. Not the subject, but a direct object. So we'll filter through that. I mean, honestly, very true, Nahar. By the way, these tweets were collected on October 26th. So there's just some context for these tweets. Right. So the election in all these sentences are the direct object of the sentence. Oh my God, I gotta stop. So now suddenly, when you look at this tree, it makes a lot less sense because it's a direct object. But now if we reverse this tree, we can see what people were talking about the election. And so the direction sort of matters when you're doing this word tree analysis. And so the election here is the direct object. So you can see what people were saying about the election when election is being used as the direct object. So like Trump wins re-election. If Biden wins the election, Trump will win the election. So that's pretty cool. Now there's a lot more practical applications. For example, parsing Amazon reviews. And I'll briefly do this with the other data set I have in the drive here. It's in a CSV format. Oh, the word tree, Nahar, is just a visualization tool. If you're actually gonna do work in Python, you can, like, there is a word tree if you look at Spacey, and you can do analysis, just not with the visualization. You have to just look at the actual. Oh, go ahead, Ismail.
Question in the Q&A. Did you collect tweets manually or using Twitter API?
Oh, I use the Twitter API. Yeah, I didn't collect them manually.
Thank you.
Right, so Amazon. Choose files, Amazon reviews. And this time we're using a CSV, so for anyone that sees pandas, we'll be using pandas for this example. This is what the data looks like. You can see from the content here, this is about Alexa, or I think Echo. The Echo Dot, yeah. So these are Amazon reviews about the Echo Dot. We're going to define similar functions to clean the data, split them into sentences. And as a more practical application, we want to look at what customers are saying about Echo Dot. Is it a good product? Is it bad? Well, let's filter the sentences by dependency. Let's say when Echo is a nominal subject. And you guys can play around with it since you have your own Colab instance open. But let's see what consumers are saying about Echo. And we'll type echo for the keyword. Okay, echo dot, and you can see consumers saying it's pretty great. Echo dot is stupid. Okay, echo dot is much better than echo dot. So yeah, so with these dependencies, you can filter for the sentences that you want. You can filter for, adjectives that describe the subject that you want described. And there's all sorts of different things you can do. You can look at the entities. You can, once you have the entities, for example, from doc.ents, can we use a combination of two words? This is a good question. For example, in noun chunks, you can, but it comes down to how you program the tokens, the tokenizers. I don't think Spacy offers, Spacy is very streamlined. So they only have one letter or one word tokens. There are other natural language processing libraries that support multiple word tokens, but it's possible. You just have to look at the documentation, because I'm not sure if Spacy supports that by default. Right. So yeah, there's all sorts of different applications you can do. You can look at the entities. You can extract the entities and then look at, what adjectives are describing Google, for example. And so what I gave you guys in this workshop is just the building blocks for natural language applications that you can use. And so I'd like to close off this workshop by going back to the PowerPoint. Screen share. Okay. So here's the Google Drive. I have these two links here. I'll upload these slides to the Google Drive as well, so you guys can have a look at them. But LexNLP, I want to show you guys, it's a real world app. Oh wait, I got to switch screens again. It's a real world application of how to sort of use the tools I just described. And we'll have a look at what they did here. So they're using natural language processing for processing legal text. And you can see they described using an NLP library. In this case, they used NLTK, but it's pretty similar to Spacy. They described, constraints, legal constraints, a list of conditional statements, extracting addresses, amounts, parts of speech, this type of stuff. And so LexNLP is being used by legal firms all over the country to sort of automate the processing of legal documents. And natural language processing, you couldn't do it without natural language processing. I mean, lawyers get paid thousands of dollars to learn all these words and what they mean, but with a computer, you can just, scan a document, look at what the entities are described, how they're related, how they're related. So this is a cool real world application. They got a lot of cool examples here. And so you can install LexNLP if you're interested in processing legal documents, if that's a valid hack idea. And back to the presentation. There's also a similar thing called Spacy. Oh, I got a question here from Linghao. Is Spacy similar to scikit-learn or TensorFlow? It's similar in the sense that it's a Python library, but they're completely different in terms of application. Spacy is a natural language processing framework. It does all the things I described, like tokenizing, and it uses things from scikit-learn because a part of natural language processing is machine learning. But no, it's not a machine learning framework like scikit-learn or TensorFlow. It's natural language processing. So yeah, there's Spacy, which is a custom Spacy library for processing scientific texts. And once you go beyond like Python, there's all sorts of ways you can integrate. And if I have more time, I'll show you. So that's the end of my workshop. But if anyone wants to stick around, there's a lot of cool cutting edge NLP stuff I can show. So let me switch back to Chrome. So yeah, that's in my workshop. If you want to leave, feel free. I just want to show you what those GPT-3 apps I mentioned were. And so GPT-3 is the language generation model. It's basically the cutting edge in natural language processing. And there's a lot of cool things you can do with it. For example, I described legal text. GPT-3 is helping translate. Okay, here's the link. It's helping people translate legal text into plain English. And so at the very high level, this is the stuff you can do with a natural language processing. For example, you can train an NLP model on legal clauses, and then the labels would be the plain English. So you can translate from legal to plain. And these are two training examples that this researcher had. And then what GPT-3 can do is once you feed it training examples, you can convert, legal clauses into plain English. And there's like infinite possibilities for how you can go about training these NLP models. There's a lot of interplay between NLP and machine learning. So I hope this workshop was a pretty good primer into the foundations of NLP. There's a whole lot of new stuff that hopefully can build off your existing knowledge to look at. A lot of cool research going on. And yeah, that's my workshop. Thanks for coming, guys.
If you guys are sticking around and have any questions, just raise your hand and I can unmute you if you would rather talk on the mic.
Any questions? What classes teach this concept? Honestly, at Penn State, not many. Like, I don't know any at Penn State. I'm in Comp Sci 442, and they briefly touch on natural language processing. But I don't know if there's any NLP classes. So yeah, Penn State could really use one, honestly. But that said, there's tons of online resources. Like, you honestly don't need college education to get into code. So, just go to YouTube, Coursera, a lot of online resources. Do you recommend any resources to learn about NLP and to practice? Right. So, as I said, YouTube is a great resource. You can look up any areas of NLP. There's bound to be a tutorial on that aspect. There are tons of free online NLP classes from, like, for example, Coursera. You'll have to do some research if you're serious about like doing a class. But if you're just casually interested, then yeah, I highly recommend playing around with some examples in Python, following some YouTube tutorials. And in the end, like, those YouTube tutorials will teach you how to integrate them with apps, which classes don't really teach you. Like, classes teach you techniques, but they don't really teach you how to integrate them with, a website or an app. So I highly recommend YouTube. Is speech to text a part of NLP? Speech to text uses NLP, yes. It also uses machine learning to translate to words. But once you have that, the distribution of what words are, natural language processing is necessary to sort of sort out the context of what the person's saying. Like, because, for example, we have a lot of homophones in English. And so we need NLP to determine, is the person saying this particular word? Oh, look at this. He's talking about this particular subject. So obviously it's this word. So NLP is necessary to sort out those contexts. Any other questions? All right. Yeah, I'm glad you can use it for your data science class, Peter. It's an aid. It's part of the sort of data pipeline for speech to text. I'm not exactly sure how speech to text algorithms work, but I imagine they use some sort of NLP to structure the sentence, because you can't just, translate my words to text. You need to put it into a sentence in the right grammatical context. So yeah, NLP is an aid in that regard. All right. Doesn't look like we have any more questions.
Okay, thank you guys so much for coming. Great job.
Yeah, thank you guys.
So interesting. I've really never seen anything like it. So we'll see you guys at the next webinar. Thank you for coming. Bye, guys.
Thank you all.